all of us are doing great. Today we're going to look at the quotient rule. And of course, the quotient rule is going to give us a specific or a general formula that is going to be applicable insofar as quotient functions are concerned. So in this case, we're going to have an example, or rather use it, or rather do an application in terms of a theorem, whereby we are going to have two functions, whereby if g and f are differentiable. These are two functions. G and f represent two functions are differentiable at x, and if gx is not equivalent to 0, then f over g is differentiable at x, and the f, this is going to be given as f over g prime of x is going to represent a derivative which can be expressed in terms of gx f prime of x minus fx g prime over x, and then this is going to be all over gx. So this is going to be gx squared given as such. So basically, if we try to look at this specific rule, is going to apply two particular concepts. In our last discussion, I talked about the concept of the reciprocal rule, and of course, in this particular representation for the quotient rule, we're going to see an aspect of the reciprocal rule being expressed, especially if we try to look at the denominator of this particular representation. So therefore, this is going to be the case, since we are going to consider that basically f over g can be represented as f, the product of f and 1 over g given in that specific order. Now for the case of the second part of this specific product, I've mentioned the concept of the reciprocal rule, whereby we are given 1 over g prime over x given in terms of negative 1 over gx, and this was a square, and then g prime over x given as such. So this was the expression that I had used to represent the reciprocal rule, and therefore whenever we're going to have a factor of this specific quotient being expressed in terms of a reciprocal, we're going to see that one being expressed in this particular case. So I'm going to do away with this, and basically, as we can see from this particular functions, we're going to hold one function constant and then find a derivative of another. So the product of these two specific elements are going to form the first set, or the first term of this numerator, and then we're going to have the second term of the numerator, which is minus. We hold this particular, of course, function which was differentiated in the first case constant, and then we differentiated the second respective function in that particular case, and this is going to form a range of the numerator of this specific derivative. So therefore, for the denominator, we're going to see this element of a reciprocal rule being applied, as I've mentioned. So let's check out whether this basically is going to be the rule. And we're going to consider the general case whereby we're going to have f prime, or f over g, and this is the function of x given as such. And this, as I said, can be given in terms of the two functions for x and g given as such. So therefore, this can be expressed as well in terms of the f function of x, and then 1 over gx given as such. And this is going to assist us to apply the quotient rule, which we had mentioned in our last discussion. Now, from the quotient rule, we had said that we can give the function of the derivative of that specific reciprocal, so long as this specific function, as we said, exists. And we had said that this particular function for g of x is not equivalent to 0 as such, and that's going to give it a condition, of course, as we said, that as long as that particular function of x exists. So therefore, we are going to express f over g prime over x given in this specific order. So now, from the quotation over that specific quotient rule, we had said that we're going to differentiate the first function and hold the second function constant, which was given in this specific order. And then for the second case, we're going to hold this particular function that was differentiated in the first case, whereby we're going to have this particular. So this is going to be plus fx. So we're going to hold fx in this specific case. Remember, we have given this particular expression in terms of course, a reciprocal. So therefore, we're going to consider the derivative of this specific reciprocal, which we're going to do in the second case, having held this fx constant. So therefore, we're going to have this one given in terms of negative 1 over gx. And as we said, this was to square and then over this one. And then we're going to have this one multiplied by the g prime over x given in that particular order. So that's going to give us a general representation for this specific case for the reciprocal of this specific quotient, whereby we are going to have a gx as a function held constant, and then we have f prime of x given as such, and then minus the second function is going to be a minus due to this particular factor. So therefore, we're going to have a f prime or f of x held constant, and this second one is going to give this g prime of x. So remember, this is going to appear as a numerator, since it's going to be given in these terms in parts of a fraction, and then we're going to have the whole of this one divided by the gx, of course this is going to be a square given as such. So we have considered this negative sign, and of course we're going to see that this specific function is going to be considered with respect to this first one, and therefore that's going to give us a general representation for the quotient rule, which we had stated in our first case. So this one, among others, we have talked about the concept of the reciprocal rule and the chain rule. They are going to collaboratively act together insofar as various functions, which of course we have seen this one being expressed in terms of a reciprocal given as such, and of course they are going to be collaboratively working together in order to give us the final general representation of various rules that we come across. So that is it for now. In our next discussion, we're going to look at a general example and try to see how we can be applying these various rules that we discuss for, of course, solving or evaluating other functions that we come across. So that is it for now, guys. By God, please catch us in our next video.